Hi everybody, thank you Lewis for kicking us off. Yes, I'm going to talk about cities and citizen empowerment. I am the founding partner of Umbrellium, and basically what we do is we build tools for citizen engagement and for citizen empowerment, by which I mean that we're always trying to build things that enable people to connect together to do things that they wouldn't have been able to on their own. I'm actually joined by a couple of colleagues that you might have seen earlier, Andrew down there and Ling, and tomorrow others from the team are going to be coming back. Just by way of background, I'm actually trained as an architect, and the kind of work that we do spans quite a broad spectrum of large-scale, spectacular projects that get thousands, sometimes hundreds of thousands of people involved, but also platforms that actually use the web or the internet to connect people together to do stuff. I'm going to be talking about a little bit about my take on smart cities and why I want to sort of say that let's be cautious about how we actually construct the paradigm of the smart city. I'm going to be talking about 3 projects very briefly, just to kind of give you an idea of the way we've approached that. I'm going to wrap up with just some of the with some of the lessons that at least I've kind of taken away from doing these kinds of projects. So this is an image of the Rio Operations Center, which was kind of touted as one of the one of these sort of epitomes of the smart city, and it's essentially a very centralized system for monitoring the city. What's interesting, what doesn't often get told, is the story that really this is basically an IBM product. It was a thing that IBM has sold to the city, and it's sold along the lines of all technology companies, talking specifically about optimization and convenience and predictability and how to make the city more kind of secure. My concern about this is that by only looking at the city in terms of trying to make it purely data model, by making it very centralized, we could very well be erasing all of the things that actually make a city valuable and desirable to live in. Because in some senses, it's the messiness of the city that actually distinguishes them. And I use the word mess not in the context of, clogged arteries and things like that, clogged roads, but mess in the systemic sense, which is that in systems theory, a mess is a system where you don't know the boundaries of all the issues or even how they interrelate. The reason that this is important for me is because you don't actually solve a mess, you just manage it. And I think it's important that, especially when we're thinking about using technology to make sense of and operate on the city, that we don't just look at the city as a problem that will someday be magically solved, because everything does interrelate. And as you fix certain things, it has an impact on other stuff. And so everything that we do needs to be accounting for the fact that there are all of these interrelationships. And we need to make sure that we don't turn the city purely into a sort of collection of screens, if you like. So when you think about the smart city, just ask yourself this question of whether this is actually the model of the smart city, or how do we actually support the diversity and the heterogeneity of the city, the unexpectedness, the surprise of the city, because that is actually where a lot of the creativity is actually derived from. The fact that things are unexpected. And my argument would essentially be that we really need to make this into a combined process involving citizens in the act of actually designing our future, designing and deciding how we are going to use things like data, use things like technology, not just for monitoring and remote control, but actually technology that brings us together to make decisions together, to make sense of our homes and our neighborhoods and our cities together. Because technology can also do that just as much as it can be about these sorts of systems of control. Now, there's another reason for just being a little bit cautious about the smart city, because when you think about the smart city as a sort of a centralized top-down system, you also need to be thinking about the smart city in terms of someone else being able to listen to and act on that data, as we've seen with the NSA in the last couple of years. You need to be thinking about the fact that personal data could get leaked if it's all centralized. You need to be thinking about the fact that Volkswagen is able to deceive us on congestion data. This is part of the smart city, just as much as the efficiencies and optimizations that come around. Tesla, you might have heard about this. They actually introduced a sort of a self-drive feature a couple of weeks ago, and within hours, videos were appearing of people's cars swerving off the road. So they were basically beta testing a feature and expecting someone else to kind of pick up the pieces. So all of this is part of the smart city. It's not going to be a smooth process. A 15-year-old boy being able to hack a whole bunch of data. This is part of the smart city as well. We need to be thinking about all of these sorts of consequences. And the last thing I want to talk about that is I want to actually show a video here. I'm sounding a little bit technologically skeptical here, and I want to sort of emphasize, because I'll be getting to some of our projects, that it's not that I'm a technological skeptic, it's that I want to make absolutely sure that we're using technology to bring us together rather than simply to centralize and have other people making decisions for us, or having algorithms making decisions for us, and then feeling as though we don't really know how to make the decisions ourselves. And I think this video quite nicely illustrates this. This was a demonstration of a self-parking vehicle that Volvo did a few weeks ago. So it's pulling back and it's going to come and drive in and park to show how its sort of autonomous parking works. So let me just show that again, and I want you to just look at the people on the left. These two here that are filming and watching. So they didn't even jump out of the way because they had so much confidence that the designers of that system had made sure that the car would act in their best interest. This is the sort of thing that I'm a little bit worried about, that if we put all of our hope purely in some abstract idea of technology, that we begin to think, well, the algorithms are going to act on our behalf. And we also have the phenomena of a Google engineer a couple of weeks ago actually described human beings as bugs in the system. And just today, or just a few hours ago, Mark Andreessen, who's one of the leading Silicon Valley investors, said, the thing about self-driving cars isn't that they'll cause fewer accidents than humans, it's that they'll be incapable of causing accidents. And it's this kind of, this kind of blind acceptance that technology somehow magically solves things for us that we're incapable of. No, it's really important that we are all part of the process of designing and creating the kinds of technology and the ways those technology are used so that we can actually make sense of and build a future together. Because we can't just rely on technology to solve all these problems for us. So what I kind of take away from this and what I'm trying to invest in the kind of works that we do is this notion of building for participation, structuring participation. Again, my background is in architecture. It's in the architecture in the sense of the built environment. But what I'm most concerned about is how do we structure the participation so that everyone can be part of that process. That doesn't mean that we all have to code, but certainly coding has to be open to anyone that wants to participate. It doesn't mean that everyone is going to be tinkering and making and hacking and doing stuff, but we need to design our systems to have the most inclusivity that we can. That actually there's many different points to enter into it. That means that we're building connections, we're building networks, we're building platforms, but most importantly, we're kind of building a sense of neighborhood. The concept of the neighborhood has changed radically, I think, over the last 20 years. It used to be that your neighbor was the person who was right next to you, geographically right next to you. Now the concept of a neighbor, I think, has been geographically exploded. So you might actually feel closer to people on the other side of the world because you are in constant contact with them in some way. And your capacity to make decisions also affects people on the other side of the world. We've got this massive interconnectivity. The sense of how we design neighborhoods, I think, has to change. The sense of how we actually construct and make decisions around data has to account for this new idea of what a neighborhood is. But we can still build neighborhoods. On that note, I'm just going to go very briefly through 3 projects that we've worked on over the last 15 years or so. Patchbay was something I launched back in sort of 2007-ish. It was basically one of the first and at the time the largest Internet of Things data platforms. Now, of course, we didn't really talk about the Internet of Things. It wasn't really a concept that was discussed so much at that time. But essentially, it was a platform for storing and sharing real-time data from a range of sensors. Weather stations, air quality monitors, seismographs, icebergs. There were ships, there were satellites on the platform, and it was basically an open system that anyone could push data to the platform and anyone could pull data from the platform. And it was used by Cisco in their urban eco map, the electricity monitor company, Current Cost, use it in their smart meter. But what I'm going to just focus on for a couple of minutes is just what happened in Japan following the radiation crisis at Fukushima, which is that everyone was absolutely concerned about radiation. The government was having a hard time actually getting information out to people. In some cases, we're only releasing PDF documents maybe once a week, where citizens actually wanted to know now, what's happening right now. And what we discovered was that within a couple of weeks, there were suddenly 2,000 feeds on Patchbay across the country measuring radiation. People had taken their Geiger counters and radiation monitors, connected them to the internet, and were pushing that data to the platform. They were creating tutorials for other people to plug in their devices. And there was a big discussion online about this citizen sensing initiative that really was a kind of a bottom-up process. At the time, there was actually a lot of criticism, especially from the sort of scientific community, about how messy this data was. Because, of course, the complaint was that there are different sensor models, people are using different units, nanogray, microsieverts. They're amateurs, they don't know how to set up or even to measure. But I think that these criticisms kind of missed the point that what was going on here was citizens actually saying, we want to be part of the process of making sense of what's going on. It was a dramatic culture change in Japan, where traditionally the relationship of citizens to government was an incredibly trusting one. We're not so used to that here in Europe, but in Japan there was historically an incredible trust, and they felt suddenly a breach of trust because they were not getting the information that they wanted. So this was basically a collective sense-making exercise, and most people were not trying to create some kind of objectively quantifiable massive data set. They just wanted to know, is their number going up or is it going down? And so we saw things like, one person actually discovered that because he actually went out and got his own radiation monitor, he discovered that his drain pipe was an incredibly high source of radiation. And on the other side of his house, it was much lower. Of course, if he had only relied on the data that was provided in that PDF, he wouldn't have known that he should move his bed to the other side of the house. And so that act of actually measuring himself helped him make a decision about his own situation. But what came next was most fascinating for me, because actually people started to do stuff with this data, even though it was messy, even though it was coming from heterogeneous sources. So Heian Zhang created what was known as the Japan Geiger maps that took the real-time data and compared it to pre-disaster levels, as well as exposure time, which is a very important part of radiation health issues, and discussed the health consequences of different radiation amounts. And this was the first map that actually enabled people to see what was going on and really understand what the actual health effects might be. There were visualization tools for understanding where the radiation seems to be peaking right now. There were visualization tools for understanding the trends over time. This kind of gave you a bit of a fly-through of the radiation levels. The Winds of Fukushima Android mobile app took wind data and wind direction combined with the radiation levels to predict where the radiation would peak next. The others included things like a form where if you didn't have a web-connected radiation monitor, you could just type in the numbers. Or you could put an SMS alert on your neighbor's Geiger counter instead of having your own, if you couldn't get your own. And you get an alert when it's peaking. And so on and so forth. All of this came out of people just wanting to do something and wanting to share that with other people, to be part of this kind of collaborative experience. And so this was the moment for me. I mean, this was sort of back in 2011, but I realized it's not just about making data public, it's also about the public making the data, going through that process of really understanding what it is that they're measuring and actually deciding that they want to do something with that data. In 2010, this is a completely different project for Bradford up in North England. We were commissioned basically to build an operating system for the built environment. Taking some of the similar principles of kind of participatory systems, what we wanted to do was basically take all the urban furniture and interactive technology that they were putting into this new space in the center of town, things like the mirror pool, the fountains, the mist machines, the LED lights on the floor, the lights up high, cameras, weather stations, etc., 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 and just make it possible to quite rapidly script interactions between all of these parts so that the council could very quickly reconfigure the city center to do things like if you connect the camera to the fountains, then you could have the fountains actually jumping as people walked past them. You could have the lights following people or running away from them. You could have things like the biggest fountain erupt every time the local team scored a goal. It wasn't that often. And so on and so forth. The idea was actually to make this into an open system where others could reconfigure the way that the city responded to them. And the process we're going through right now is actually to open it up even further so that just ordinary people walking through the park will be able to reconfigure it in a very similar way, be able to sort of build their own sort of rapid prototype interactive systems in the city space. And just to wrap up with projects, I know Andrew mentioned this earlier, Thingful.net is our latest thing. Thingful is basically a search engine for the Internet of Things. The Internet of Things is already here. There's already tons of data out there. There are air quality monitors, weather stations, seismographs, there's aircraft, ships, cars, all sorts of things around the world. All that data is already public, is already out there waiting to be used, but it's really difficult to find it. If you are concerned about air quality, for example, you can't just Google for the nearby air quality monitor, but chances are that somewhere near you, somebody else has also been concerned about air quality. And there's an increasing likelihood that they've actually gone out and bought an air quality monitor and they've plugged it into the internet and they've pushed the data to the web and they're sharing that data because they want other people to use it. But Google is not able to index that air quality monitor. If you do a Google search for air quality in your neighborhood, you'll probably at best get an article about it. You won't find that actual device. So what we do is we go out and we index all the different networks that we can find for all sorts of sensor and connected object around the world. So that, for example, if you search for air quality, you don't need to know about the AQICN network, which is a global air quality network. You don't need to know that, for example, Intel has done a deployment of air quality sensors. This is, I took this from London. You don't need to know about the Air Quality Egg network, which is a citizen sensing initiative for air quality. But all of these things are indexed so that when you go and look for them, you can find them, click through, and find the original data source, and hopefully even contact the owner of that device and make use of that data to hopefully build some kind of collaboration. So if you're concerned about air quality is one thing, or maybe it's radiation in Germany, or it's earthquakes in California, or it's wave height in the Pacific, or even in the Caribbean, you might be concerned about sharks, because there's even sharks that are being tracked and generating data these days. You can find this and make it useful. What we're trying to do is take stuff that's already out there and just make it more useful for people to actually build stuff. There is an API, which I think, again, Andrew has mentioned. You can search for the things, and you can search for based on geolocation, based on near me, etc., and you can actually get a data preview, which might not be the freshest data from that source, but you also have the URL of the data source itself, and you can follow it through. If you are interested in using the API, the URL is down there, bit.ly/thingful_docs. All of which brings me to the end, just to say we are doing a couple of projects here in Cambridge that we're really excited about. One is for Trumpington Community College, which is a new school. There's not much to show about this yet, but we've been working with them for about 6 months. It's going to be a project about the students actually using data to make sense of the building and the surrounding environment. And a project that's called, it's kind of got a working title of Cambridge Cycling or Cycle, Drive, Bus. It's essentially it's an app for helping people make the decision about whether to drive, cycle, or take the bus today. In order to do that, of course, you need a wide range of data: air quality, weather, traffic, transportation data, bike share availability, perhaps. And what we're trying to build is essentially a decentralized framework where an app developer is able to make use of all that data. The data owners have full control over who gets access to that data. And the data client can actually start to build an application on data that's already available. So the things that I've kind of taken away from this process of using data to sort of structure participation is, first, that we need to think about the dilemmas about data. It's not enough just to make data available. The question is, what is the decision that is going to be made around that data? Sometimes you might say, well, if I just give the air quality data to drivers, then of course they'll realize what a horrible mess they're making. But of course, people are driving for a specific reason that they think is perhaps it's to do with safety or comfort or perceived speed. It's not enough just to say, look, you're causing this air quality problem. You need to think about those dilemmas, I think. The question then becomes, how do you sort of take these kinds of dilemmas and look at who actually experiences them? If you put cyclists and drivers into the same room, you'll just have a big argument, right? Because actually the ones who are causing the air quality problems, namely drivers in cars, are not necessarily the ones that get affected by them, which is the cyclists that are cycling through the congested cities. So again, actually figuring out how to basically incentivize both parties to be part of a process of changing the air quality is far more important than simply presenting a map or a visualization of the data. And so that's a challenge I would throw out here for the hackathon. Find out how it is that people are going to use data to make a decision. If you're just visualizing the data, how do they use that visualization to make a decision or hold somebody accountable or change something with that visualization? What is the actual change that's going to be created? We've often found that actually people want to amass their own evidence, right? It's not just about being given a chunk of data and then sort of being able to sit back and say, okay, it's very obvious that things are going to change. No, you actually need to have evidence that you can hold people accountable to, and also to make the kind of decision that I mentioned, like in Japan, the person who actually discovered just how much radiation levels vary on such a short basis. So the final thing is, what are those tools that enable people to amass the kind of evidence about the things they're most concerned about to actually make these kinds of decisions? Thank you very much.